Welcome to this class. Today I am going to start a new chapter, Energy of class 9, and the subject is Science and Technology, and it is taken in unit 9. And today we are going to focus on different sources of energy and the nuclear fusion reaction which is constantly taking place in the sun. Okay, before we start this different sources of energy, at least we must have a little idea what sort of energy sources we are using in our daily life. What are the major sectors in which these sources of energy are used? There are different sources of energy which are used in different sectors. I want to pick up three very important sectors. One is cooking, another is transportation, another is industry. These are the sectors in which huge amount of energy sources are used every day throughout the world. So let's talk about them. Cooking: firewood, liquefied petroleum gas, kerosene, coal, briquette, dung cake. These are the sources of energy which we use in cooking. Firewood is used in villages, and liquefied petroleum gas means at first the petroleum is obtained in the form of black colored viscous liquid which contains petrol, diesel, kerosene, everything, and after the fractional distillation this petrol, diesel, kerosene are separated, and lastly a gas is left over there in the tank, that is petroleum gas. And this petroleum gas is when pressurized and converted to liquid, then the liquid petroleum gas we get, and this is supplied to different parts of the country. This is the bullet which takes this liquid form of petroleum gas, and it is supplied to the filling center. In the filling center this gas cylinders are filled with this petroleum gas in the form of liquid which we use in kitchen for cooking food. Okay, beside this kerosene is used, and this is the kerosene stove where we put kerosene in this tank and we are using this to cook the food. Kerosene is used not only in cooking, it is used to light the rooms also in different lamps, and it is used to get heat energy in the winter season to make our room hot. And beside this, coal is also used in cooking purpose. It is a solid fuel which contains mainly carbon. When it burns, it releases huge amount of energy, and that is used in cooking. But in our country the use of coal is very less. In other country coal is used a lot for different cooking purpose. And briquette is made up of mainly sawdust, and there are other agricultural waste also which can be used in making briquette, and the dried leaves are also used in making briquette. Briquette is used in cooking purpose. Now cow dung or dung cake, maybe the buffalo dung. The dung cake is dried and it is used in cooking food later, and this is one of the major energy source in the villages in cooking the food. Okay, now let's talk about other also. We are using the sources of energy in transportation and industries. In transportation, petrol, diesel, coal, electricity, etc. But in industries we use coal, diesel, electricity, natural gas, etc. Now let's talk about them one by one. Petrol we use to run light vehicles, we know about this. Motorcycle and four-wheelers are using petrol to run them, and the diesel is also the similar, but the color of diesel is a little dark yellow than that of the petrol, and it is used to run heavy vehicles. And coal, I told about the coal, and electricity we'll talk about the electricity in the electricity chapter. I'm not talking today. But coal in industry, the huge amount of coal is consumed in industries. Look at this, the pile of coal which is needed to run this industry for a long time throughout the year. That's why they collect huge amount of coal, and that is used to run these industries. And beside this, diesel, I told about this, electricity will learn in the respective chapter. And natural gas, what is it? Natural gas is obtained from the earth crust, and this gas contains mainly methane. This liquefied petroleum gas contains mainly butane, but this natural gas contains mainly methane, and it is transported to very, very long distance, hundreds of kilometers by pipelines, and it is used in cooking also, it is used in industries also, it is used to make our room warm also in the winter season. These are basic sources of energy which are used in cooking, transportation and industries. But beside this, solar energy is also used, wind energy is also used, geothermal energy is also used as a source of energy, and these sources of energy, according to their availability for long time or short time, according to the availability of the sources of energy, they are categorized into two categories. One will finish in near future, another is not going to finish in the future. This way we can divide them in two categories. One is called renewable source of energy, another is called non-renewable sources of energy. Now what are they? I want to define this. The renewable source of energy. Looking at the name also, you can understand clearly, it is renewed, it means it is available forever. We can define this way: the sources of energy which recover itself in the nature after their use due to the high rate of production than that of the consumption are called renewable sources of energy. The rate of consumption is less, but rate of production is high. Just for example, this biogas, we can get biogas from agricultural product or animal dung. We can get it for long time. The rate of consumption is less, but rate of production is high. In the same way, solar energy, we'll get solar energy forever. Our consumption rate is very, very less than that of the available sun. And in the same way, wind energy, in the same way, tidal energy, these are the sources of energy which never finish, and they are consumed a little, but their availability is very high, and they are renewable source of energy. But what about non-renewable source of energy? We can define this way: the sources of energy which cannot be recovered in the nature after their use due to the high rate of consumption than that of the production are called non-renewable sources of energy. Their rate of consumption is high, but rate of production is very less. Just for example, fossil fuel, petrol, diesel, kerosene, coal, etc. They require millions of years to form in the earth crust. But at what rate the world is using them? It's very fast rate. That's why the rate of consumption is very high, but rate of production is very less. It takes millions of years to form this fossil fuel. So they are going to be finished in near future, and that's why they are called non-renewable sources of energy. Now we can differentiate renewable source of energy and non-renewable source of energy like this. They are perpetual source of energy. What it means? They are available forever. And they are exhaustible source of energy. They are not available forever. They will finish in near future. That's why exhaustible. And usually they are pollution free. Usually. Why I said usually? Because some of them pollute the environment. Just for example, this gobar gas or biogas, when burns, it produces carbon dioxide in the air and they pollute the environment. But solar energy never pollute the environment. Geothermal energy is not polluting the environment. That's why usually they are pollution free. But almost all the renewable source of energy, all the renewable source of energy pollutes the environment. They produce certain amount of gas, certain chemicals which cannot be dumped in soil also. Okay. Now another difference is they are cheap. Just for example, this firewood is cheap, which is one of the renewable source of energy. This gobar gas is cheap in comparison with the petrol, diesel, kerosene, coal, etc. But solar energy is free of cost, and this tidal energy is free of cost. Some of them are cheap, some of them are free of cost. But here, in case of this non-renewable source of energy, they are expensive in comparison with this. Okay. After this understanding, why don't we make a list of renewable and non-renewable source of energy? Let's start to make renewable source of energy, a list of renewable source of energy. Solar energy, another is tidal energy, biomass energy. Actually, biomass energy is obtained in three different states. In solid state, the firewood, dung cake, etc. And in liquid state, alcohol. And in gas state, it is biogas. These are the biomass energy available in the form of solid, liquid and gas. Okay, now another one, wind energy, another geothermal energy, hydroelectricity and hydrogen. This is one of the important point. Hydrogen is also renewable source of energy. How can we get hydrogen? When we decompose water into two different gas, hydrogen and oxygen, the hydrogen so obtained can be used as source of energy and it can run the vehicle also. Hydrogen is one of the important rocket fuel, and hydrogen is when burned in different engine, then it combines with oxygen to form again water, and that's why this is renewable source of energy. This is a list of renewable source of energy. Now let's make another list of non-renewable source of energy. What are they? Fossil fuel. Fossil fuel, it categorized into three categories. One is coal, another petroleum, another one is natural gas. These are the fossil fuel. Besides this, nuclear fuel, for example, uranium-235 is a non-renewable source of energy. I think you know about this. It is used in nuclear power plant. When uranium nucleus is bombarded with neutron, it is split up into barium and krypton with the release of tremendous amount of energy. That energy is used to boil water. Water produces steam, and high-speed steam is used to rotate the turbine, and turbine runs generator, and generator generate electricity which is used in different purpose. This way, nuclear power plant uses uranium-235, and this uranium is very expensive. It cannot be obtained easily. So it is non-renewable source of energy which will finish in near future. Okay, let's talk about the fossil fuel. How it forms. It takes millions of years for the formation. How fossil fuel forms? We can say this way. The fuel formed in the earth crust by the decomposition of the fossil of plant and animal at high temperature and pressure in the course of millions of years is called fossil fuel. In ancient time, certain forests were buried into the ground, and the sea plants and animals were also buried into the ground, and they came under the high temperature and high pressure. But high temperature, high pressure, in the absence of oxygen, they decompose. And because of this decomposition, they converted to fuel. What sort of fuel? Petroleum, coal, natural gas. This way the fossil fuel forms. Now, heat energy obtained by the burning of the fuel, fossil fuel, like coal, petrol, diesel, etc. is called fossil fuel energy. Now, among these three fossil fuel, first is coal. I want to talk about the coal, how it forms, and then petroleum, and then natural gas. Look at this formation of coal. In ancient time, many forests were buried into the earth crust, which came under high temperature and high pressure, due to which plant body decomposed to form coal in the absence of oxygen. This process is called carbonization. Now, one point you have to remember, when forest goes inside the ground for very long time because of very high pressure, because of high temperature, but in the absence of oxygen, it won't burn. Because of high pressure, the hydrogen and oxygen contained in the body part of the plant will escape out, and only carbon is left behind. And this process is called carbonization, which forms the carbon mainly in the form of coal, which left carbon only in the form of coal. This way coal forms, and it takes millions of years for the formation. Now next, petroleum oil, how it forms. Now this is the petroleum oil. This is crude oil, and actually it contains petrol, diesel, kerosene, everything. Now we have to go through fractional distillation to separate petrol, diesel, kerosene from this crude oil. Now how it forms? Actually, petroleum oil is a dark viscous liquid and a mixture of petrol, diesel, kerosene, etc. having a foul smell. Its smell is very bad. Now how it forms? In ancient time, plants and animals of the sea were buried into the earth crust, which came under high temperature and high pressure, and in the absence of oxygen, this organic matter decomposed and converted into petroleum oil. Actually, big plant body forms coal, but small plants which are found in the seabed and small animals of the seabed, or maybe a little larger in size of animal in the seabed, when comes under the ground, I mean to say comes under the earth crust, then because of high temperature, high pressure, it converts to petroleum oil. Now let's think about another point. If this petroleum coal takes millions of years for the formation, and we are dependent on this petroleum coal, natural gas, then certainly after few decades, maybe 4 decades or 5 decades or 6 decades, they are going to be finished from this earth. If they finish, then what happens? Then we'll have scarcity of the source of energy, because we are dependent on them. We are not using solar energy a lot. We are not using this wind energy a lot. That's why that condition, when there is scarcity of the energy source, is called energy crisis. Exactly how can we define energy crisis? Energy crisis means the scarcity of energy sources in near future due to the overuse of the fossil fuel at present is called energy crisis. Now, how can we escape out of this problem, energy crisis? There are certain methods. These are the methods. Number 1, increasing the use of renewable sources of energy like hydroelectricity, solar energy, biofuel, etc. If we increase the use of these renewable sources of energy, then energy crisis can be pushed away. Now, second, conserving the present source of energy. Conserving the present source of energy. The present source of energy, we have crude oil and petroleum oil, coal, etc. If we conserve them, then energy crisis can be pushed away. Now next, reducing the use of non-renewable sources of energy, that is fossil fuel. As far as possible, it will be better to use this renewable sources of energy, but not the non-renewable sources of energy. Now next, controlling the population growth. Population growth is one of the major factors which will bring this energy crisis nearer and nearer. If population is more, then certainly more sources of energy is used for different purpose, and that's why the population growth should be controlled to push this energy crisis away. So these are the methods to escape out from the energy crisis. Now it's time to talk about the nuclear energy and nuclear reaction, and the nuclear reaction which is constantly taking place in the sun. Let's talk about this. What is nuclear energy? We can say this way: energy produced by the nuclear reaction is called nuclear energy. But exactly what is nuclear reaction? We know about the chemical reaction. In the chemical reaction, electrons takes part in the chemical reaction. Either the electrons are shared between the atoms, or electrons are donated and accepted, and this way chemical reaction takes place. We know about this, it is taught in chemistry, but nuclear reaction is completely different than this. It is not related to the electrons of the atom, it is related to the nucleus. That's why we can define this way: the reaction in which the nucleus of the atom takes part and tremendous amount of energy produces due to the destruction of mass is called nuclear reaction. These are the characteristics of nuclear reaction. Nucleus takes part and a part of the mass is destroyed in this reaction, and this destroyed mass converts to tremendous amount of energy. Now this nuclear reaction is of two types. One is called nuclear fission, another is called nuclear fusion. Now what is nuclear fission? In nuclear fission, actually a heavy nuclei splits up into comparatively light nuclei with the release of tremendous amount of energy, and destruction of a little mass also takes place. That's why we can define this way: a nuclear reaction in which a heavy nuclei splits up into two or more comparatively light nuclei is called nuclear fission. For example, in nuclear power plant, uranium nucleus splits up into krypton and barium with the release of tremendous amount of energy that is used to run generator to produce electrical energy. This is the example of fission. We have to remember that heavy nuclei splits up into light nuclei in nuclear fission. But in nuclear fusion, just opposite of this, light nuclei fuses with each other to form heavy nuclei with the release of tremendous amount of energy. In this process also, a part of the mass is destroyed that converts to tremendous amount of energy. So we can define this way: nuclear fusion is a nuclear reaction in which two or more light nuclei fuses with each other to form a comparatively heavy nuclei. For example, hydrogen nuclei are constantly fusing with each other in the sun and in stars to form helium with the release of tremendous amount of energy. You are taught a little about this. Hydrogen fuses with each other to form helium. In this process, tremendous amount of energy produces, and that we are getting in the form of light energy and heat energy from the sun. In all the star, in almost all the stars which can be seen in the night sky, the same thing is happening. I mean to say, nuclear fusion is taking place in the center of those stars. Okay, if it is so, then what amount of energy produces in the nuclear reaction? It was given first by Einstein, and he gave one of the very important equation that is called mass energy relationship of Einstein. I want to tell you about the mass energy relationship given by Einstein. What is it? Einstein gave a relation of mass destroyed and the energy produced in the nuclear reaction. According to him, the equation is E equal to mc square. Here, E is energy produced, m is mass destroyed. Remember this, not only mass destroyed, and c is velocity of light in vacuum. Okay, now this E equal to mc square, using this equation we can solve the numerical problem also. Now it's time to talk about the nuclear reaction which is constantly taking place in the sun. What is happening in the sun? The surface temperature of sun is very less, that is about 5700 degrees Celsius. But the temperature at the center is very high, that is 15 million degrees Celsius. That means 1 crore 50 lakh degrees Celsius temperature in the center. And because of this very huge temperature, the nuclear reaction takes place in the center. And here in the center of the sun, there is tremendous pressure also. Because of huge temperature, tremendous pressure, hydrogen nuclei fuses with each other to form helium constantly in the center of the sun, and that produces tremendous amount of energy. Now I am going to show you the nuclear reaction which takes place in the center of the sun. Okay. Before that, I will tell you something other than this. If an atom has to be represented, atom of an element, let's say this is an element which is denoted by E, its atomic number is denoted by Z, its atomic mass is denoted by E. It means this is the symbol of the element and its atomic number is written in left hand side at the bottom, and its atomic mass is written in the right hand side in superscript. Now exactly what it is, if we have to write sodium in a nuclear reaction, then sodium symbol is Na and its atomic number is 11, its atomic mass is 23. We have to write this way in the nuclear reaction if we have to represent sodium. In the same way, if we have to write uranium, then we write this way: uranium symbol is U, atomic number is 92, and atomic mass of the uranium is 235. We have to write uranium like this in the nuclear reaction. This, you must know about this first, and then we have to understand about, we have to remember the isotope also. Do you remember what is isotope? Isotope means the elements having same atomic number but different atomic mass is called isotope. Hydrogen has got 3 different isotopes. What are they? One is called protium, hydrogen atom having atomic number 1 and atomic mass 1. This is called protium. And hydrogen is available in this form also. Hydrogen having atomic number 1, it means number of proton is 1, but number of neutron is also 1. And this is heavier than the first, and its atomic mass is 2. Number of proton plus number of neutron gives atomic mass. This is called deuterium. And another is tritium. Tritium has got 1 atomic number, but atomic mass is 3. What it mean? It has 2 neutron and 1 proton. That's why its atomic mass is 3 and its atomic number is 1. This is tritium. Tritium, tritium. Now, this we must remember. What? Protium, deuterium, tritium, they are symbolically written like this. If we have to write subatomic particle like electron, proton and neutron, electron, proton and neutron, then we will not write like this. We will talk about their charge. Electron has got 1 unit negative charge. That's why I am writing -1 here in left hand side at the bottom. Proton carries 1 unit positive charge, right? I am writing +1 in left hand side. Neutron carries no charge and 0. But their relative mass, the mass of the electron is negligible. That's why I am writing here 0. Mass of proton, relative mass of proton is 1. That's why I am writing 1. And protons and neutrons are almost equal in mass. That's why I am writing here 1. That's why in nuclear reaction, if we have to write electron, then we will write this symbol. If we have to write proton, this symbol. If we have to write neutron, this symbol. There is another particle also which carries 1 unit positive charge, but its mass is supposed to be 0. This is called positron. Electron, proton, neutron, positron. Okay, after the understanding of all these symbols, now we are able to write nuclear reaction which is constantly taking place in the sun. Now let's talk about the nuclear reaction which is constantly taking place in the sun. What is happening in the sun? First, this protium, which is denoted by this symbol, combines with another protium to form deuterium. Deuterium, its symbol is this. And in this process, positron also produces along with tremendous amount of energy. Look at this reaction. Nuclear reaction I am writing in a step. There are 3 major steps. According to your book, it is represented differently in different books, but I am following your book. This is the first step. Protium combines with another protium and forms deuterium along with the positron and energy. And secondly, what happens? This deuterium again combines with protium to form light helium. Light helium has got atomic number 2 but atomic mass 3. Along with the energy may be written in the form of gamma rays, and it produces tremendous amount of energy. Look at this. And again, third step, this light helium combines with another light helium to form normal helium. And in this process, look at this, 3 plus 3, total atomic mass is 6, but here we have only 4. And 2 is left, that's why 2 protium nuclei separates from this helium. This 2 protium nuclei separates from this helium. It can be denoted like this. It can be represented by this symbol with the release of tremendous amount of energy. This way, actually, nuclear reaction occurs in 3 different steps. Protium combines with protium to form deuterium along with huge amount of energy, and deuterium combines with again protium to form light helium with the release of tremendous amount of energy. Again, light helium combines with another light helium to form normal helium with the release of tremendous amount of energy. We can take sum of all these reaction is actually 4 protium nuclei are fusing with each other to form one helium nuclei with the release of tremendous amount of energy. In this process, positron also produces, releasing tremendous amount of energy. This way, the nuclear reaction is constantly taking place in the sun. Okay. Now, after this, I want to mention some other matter also. Maybe somewhere given this way also, hydrogen, this protium combines with another protium to form deuterium along with the energy. This protium plus protium forms deuterium, and this is again deuterium combines with protium to form tritium. Somewhere may be written like this. This is not, we can say that this is incorrect. Deuterium combined with protium to give what? Tritium. And another step may be written tritium combines with tritium to form helium, and 2 protium are released out, and this way tremendous amount of energy is produced. Don't be confused, maybe a little different type of nuclear reaction written in some cases in certain internet or other books, but there are some steps in which protium combines to form deuterium. Deuterium again combines to form light helium or tritium, and again they combines to form helium. In every step, huge amount of energy produces due to the destruction of mass. Now, what are the reasons this reaction is taking place in the center of the sun? Actually, this reaction takes place in the center of the sun, but what is the reason behind this? We can say this way. First reason, very high temperature. Is the temperature of the central part of the sun is very high, and it is necessary for the separation of proton from electron in hydrogen atom. Hydrogen atom contains electron also. Electron separates out and gives only proton, and this proton is further used in the chain reaction like this. And second, tremendous pressure. Tremendous pressure is over there, due to which proton combines with each other because of the pressure, and then the helium produces. That's why tremendous pressure is needed, and it is over there in the sun. Not only in the sun, in every star same thing is happening. Third, presence of huge amount of hydrogen. Hydrogen is the major fuel for the nuclear fusion reaction, and 90% or more than 90% of the total mass of sun is of hydrogen, and which is major fuel for the formation of what? Helium, or for the nuclear reaction. That's why this is one of the major reason of nuclear reaction which is constantly taking place in the sun. Or we can say this point also, this is a little less important point. Presence of helium also helps to create the pressure in the central part. Okay, these are the reasons of nuclear fusion in the sun. Now, after all this, I want to solve one numerical problem related to nuclear fusion reaction using Einstein mass energy equation. Okay, look at this. Let's say the destroyed mass in a nuclear reaction is 0.1 gram only, very less. 1 gram is very, very little, and 0.1 gram of hydrogen means very less mass. And how much amount of energy produces in the destruction of this 0.1 gram of mass? This is the question. And we are using E equal to mc square. And we know that the velocity of light, that is denoted by c, is 3 into 10 to the power 8 meter per second. We know this. Now, using this equation, E equal to mc square, we can get the result. This 0.1 gram is equal to, gram doesn't work because we have to convert this into kilogram, because we are getting energy in joule. If we are going to measure energy in joule, then mass should be written in kilogram. That's why 0.1 gram means 0.1 is, if divided by 1000, then it comes in kilogram. This is equal to 0.130, that's why 10 to the power minus 4 kilogram. You can use calculator also. Okay, now in place of mass I am writing 10 to the power minus 4 kilogram. In place of C I am writing the value of C. What is it? 3 into 10 to the power 8 meter per second and whole square. Now this is equal to 10 to the power minus 4 kilogram into 3 3s are 9, 3 square means 9, into 10 to the power 8 square means 10 to the power 16, and meter square by second square, unit also square. Now this power of 10 interact with power of 10, number interact with number. There is only one number, 9. I am writing 9. 10 to the power minus 4, 10 to the power 16 gives what? 10 to the power 12. 16 minus 4 is 12. And kg meter per second square is Newton. And one of the meter is left. Newton meter is joule. That's why we can write this joule. Therefore, energy released is equal to 9 into 10 to the power 12 joule. This is very huge number. This is about 90 kharab joule. When 0.1 gram of hydrogen is destroyed, then 90 kharab joule energy produces in this nuclear reaction. Very interesting. Okay, today I told you about the different sources of energy, renewable source of energy, non-renewable source of energy, and the nuclear reaction which is constantly taking place in the sun. We wrote some nuclear reaction also. Okay, now I am going to stop this class. We'll meet in another class with some another matter. Thank you.